At every altitude you can see the environment is having greater temperature than the air parcel. At every altitude, either that is surface or 1 kilometer or 2 kilometer or 5 kilometer, anything, you can see the environment is having higher temperature than the air parcel. As I have already told you, the stability condition is that when environment is having higher temperature than the air parcel will become stable. So you can see this is the condition of absolute stability, when at every altitude the atmosphere or the surrounding which is having higher temperature with respect to the air parcel or the closed thermodynamic system, as I have told you in previous case. Okay, at every altitude the atmosphere is having higher temperature. So you can see the graph here. So this is showing temperature. In x-axis we are taking temperature, and in y-axis we are increasing altitude. So we can see at near surface both are having equal temperature, and in all of the above cases, in all of the altitude, you can see this is for environmental temperature, this is for environmental temperature or environmental lapse rate, decrease in environmental temperature with height. So you can see that is your environmental lapse rate. It is dry adiabatic, air is unsaturated. It is wet adiabatic when air parcel is saturated. You can see in all cases the air parcel is having lesser temperature than the environment. In all cases you can see the air parcel is having lesser temperature. You can take any altitude. This is 2 kilometers. This is 4 kilometers. So at every altitude the air parcel will have lower temperature as compared to the environment or its surrounding at that particular altitude. So in that case, what happens when the air parcel is having lower temperature, there is not a condition that air parcel will become buoyant. As I have told you, when the air parcel is having higher temperature, then that will lead to development of vertically developed clouds or cumulus or cumulonimbus cloud. So when the air parcel will have lower temperature as compared to the environment, then that lead to formation of stable clouds or strata-like cloud. You can see here there are horizontally developed cloud. There are horizontally developed cloud which are spread horizontally like stratus. So the name of the cloud is stratus. Name of the cloud is stratus. We are going to study the classification of clouds, but you can see here the clouds are developed horizontally in stable atmosphere, and the clouds are named as stratus cloud. It doesn't mean that when that is stable atmosphere there is no precipitation. I have already told you, in stable atmosphere precipitation can take place, but that is due to the greater diameter of the moisture or greater diameter of the water molecule, so that gravity will attract that moisture and it will fall towards the surface. So stable atmosphere that lead to precipitation, but that doesn't lead to thunderstorms. Thunderstorms taking place only in case of unstable atmosphere, but in stable atmosphere we can see precipitation, we can feel precipitation in stable atmosphere, but there is not severe atmospheric conditions. Okay. So this is all about absolute stability. As I have told you, the environment is always with higher temperature as compared to the air parcel. So next we are going to discuss absolute instability. Here you can see the stability condition and instability condition. In stability condition it will develop horizontally developed clouds, okay, and in instability condition or unstable atmospheric condition that will lead to develop vertically developed clouds, as I have told you, cumulus or cumulonimbus clouds. And when the air parcel will be stable, during the night time the air parcel is always stable because the near surface is having lower temperature. The near surface is having lower temperature. The air parcel will be lower temperature due to radiational cooling of Earth. At night what happens, the earth will radiate the solar energy that it has received during the morning. Okay, at night time it will going to radiate that long wave radiation, so the surface will become colder. When surface is colder, the air parcel is colder. If air parcel is colder than the environment, the air parcel will rise, but the environment will have higher temperature than the air parcel. So that is the condition of stability. But during daytime what happens, the surface gets heated, so the air parcel will have higher temperature. So when it rises to the upper atmosphere, the environment is having lower temperature than the air parcel. When it rises to upper atmosphere, it will cool down. Obviously it will get cooled, but at a particular altitude, what happens, the air parcel will have higher temperature than the environment. So that is the condition of instability, as I have mentioned here, that air parcel is having higher temperature than the environment, which is lead to unstable atmosphere. That is generally during the daytime. We are generally watching that in during daytime there is precipitation when there is some instability or unstable atmosphere. Okay, so we are going to see that the condition of absolute instability, when that will have absolute instability condition. Now we can see here the environmental temperature, as in previous case you can see the environment which is nearer to surface, that is it is having a temperature of 40 degrees centigrade, and here the environmental lapse rate is 12 degrees centigrade per kilometer. Environmental lapse rate is 12 degrees centigrade per kilometer. You can see at surface it is having 40 degree centigrade temperature. At 1 kilometer altitude it is 28 degree, then 2 kilometers 16, and like that it will become 4 degree and minus 8 degree as it rises off. Then talking about air parcel, you can see the air parcel when it is nearer to surface, it is having 40 degree centigrade temperature, and as I have told you, that is unsaturated. So the dry adiabatic lapse rate is 10 degree centigrade. I have told you that is fixed. Dry adiabatic lapse rate is 10 degree centigrade per kilometer, and moist adiabatic lapse rate is 6 degrees centigrade per kilometer. Okay, so the air parcel will have temperature 40 degree, then at 1 kilometer altitude it will have 30 degree and 20 degree centigrade. You can see here at 20 degrees centigrade temperature the air parcel is getting saturated, because at that much amount of water vapor that attended the saturation vapor pressure at 20 degree centigrade, so the air parcel will become saturated. Here the relative humidity becomes 100%, because the absolute vapor or absolute moisture is equal to saturation vapor pressure. That means if in the previous case I have taken the example, let's say at 40 degrees centigrade it is containing 40 gram water vapor, but it is unsaturated because at 40 degrees centigrade it requires let's say 80 gram water vapor to get saturated. But when it contains 40 gram and its temperature is 20 degrees centigrade, you can see here the temperature is decreasing, the vapor amount is constant, the moisture content is constant. So the moisture content is constant, I am decreasing the temperature. So when decrease in temperature, there is decrease in saturation vapor pressure. At 20 degrees centigrade, it can get saturated with 40 gram water vapor, but at 40 degrees centigrade, it cannot get saturated at 40 gram, it requires 80 gram, it requires more 40 gram, right? So at 20 degrees centigrade, it will get saturated. That doesn't need 0 degree centigrade temperature. So after the saturation, we are going to apply moist adiabatic lapse rate or wet adiabatic lapse rate. So you can see here it is 20 degree and here 14 degree. The moist adiabatic is 6 degree centigrade per kilometer. So it will decrease to 14 degree, then 8 degree, and then continuing. So you can see here at every altitude, for every altitude you can see the environment is having 28 degrees centigrade, the air parcel is having 30 degrees centigrade. That means in the system and surrounding. This is our system or air parcel, and it is our surrounding. The system is having higher temperature as compared to the surrounding. So there is increase in buoyancy. Buoyancy means upward driving force. So the air parcel will grow vertically at from that altitude. So you can see when it is unsaturated, it cannot lead to formation of cloud. I have already told. When it will become saturated, then there will be formation of clouds. That is unsaturated, that doesn't lead to formation of clouds. So this is the unsaturated condition. You can see the atmosphere is having lesser temperature as compared to the air parcel. At this altitude 2 km, you can see the air parcel is having greater temperature than the atmosphere. At this altitude, let's say 3 km, the atmosphere is having lesser temperature as compared to the air parcel. Here the air parcel is having higher temperature, so there is increase in buoyancy, so they will lead to formation of vertically developed clouds because of their vertical growth. They will lead to formation of cumulus and cumulonimbus cloud. That will lead to formation of thunderstorms like events or low pressure like events. Okay, that will lead to formation of atmospheric unstable condition. So this is the condition when the air parcel will be heated more as compared to the environment. The air parcel will have higher temperature as compared to the environment, and it is taking place when there is solar heating during the daytime. Okay, now you can notice the graph. You can see the graph here. This is showing environmental temperature, this is showing environmental temperature or environmental lapse rate, decrease in environmental temperature with height. You can see this is dry adiabatic lapse rate and this is moist adiabatic lapse rate. So you can mark at every altitude the air parcel is having higher temperature. The air parcel temperature is this one, this is our environmental temperature. This is altitude. At every altitude the air parcel will have higher temperature as compared to the environment. So this will lead to absolute instability condition, and that is lead to formation of thunderstorm like event and greater amount of precipitation and vertically developed clouds. Okay, so we can see the condition here. The environmental lapse rate is 12 degrees centigrade. That is an example, right? That is an example. For a dry adiabatic, that is 10 degrees centigrade, and moist adiabatic, that is 6 degrees centigrade. And here you can see the sequence. Environmental lapse rate is greater than dry adiabatic lapse rate is greater than moist adiabatic lapse rate. So this is the condition for absolute instability. These patterns they are repeatedly asked in the NET exam. So you can note the sequence that when environmental lapse rate is greater, that will lead to absolute instability. And in previous case, for stable atmosphere, you can see the environmental lapse rate is 5 degrees centigrade per kilometer, dry adiabatic lapse rate is 10, and moist adiabatic lapse rate is 6. So here dry adiabatic lapse rate is greater than moist adiabatic lapse rate is greater than environmental lapse rate. So this is the condition for absolute stability. This is the condition for absolute stability when environmental lapse rate is lower than the dry and moist adiabatic lapse rate. When environmental lapse rate is higher, then that will lead to unstable atmosphere. Then we are going to discuss the conditional instability. Now talking about conditional instability, you can see here the environmental lapse rate is 8 degrees centigrade per kilometer. It is an example, as I have told. The dry adiabatic lapse rate is 10 degrees centigrade per kilometer, that is constant. moist adiabatic collapse rate is 6 degrees centigrade per kilometer. Okay, so you can see the environmental temperature is 40 degrees centigrade near surface. When it will rise to 1 kilometer altitude, that will have 32, then 24, 16, 80, like that. Talking about the air parcel near surface, it is having 40 degrees centigrade temperature. At 1 kilometer altitude, it will have 30 degrees centigrade temperature, then 20 degrees centigrade. When it becomes saturated, it will have saturation at this altitude. At 2 kilometer altitude, it will become saturated. So here we are applying dry adiabatic. Now we are going to apply moist adiabatic. So that is 6 degrees centigrade. You can see from 20 degree it will decrease to 14 degrees centigrade in 1 kilometer altitude, then 8 degree, 2 degree and minus 4 degree respectively. Now you can compare for air parcel and surrounding temperature at every altitude. At near surface it is same. At 1 kilometer altitude, the environment is having 2 degrees centigrade temperature higher than the air parcel. Here the surrounding is having higher temperature than the air parcel. At 2 kilometer altitude, it is having 4 degree higher. The environment is 4 degree higher than the air parcel. At 3 kilometer altitude also, it is having greater temperature. The environment is having, or the surrounding is having greater temperature than the thermodynamic system or the air parcel. At 4 kilometer altitude, there will be same temperature. Environment is having same temperature at the air parcel, and above that the air parcel will become will have higher temperature as compared to the surrounding environment. So when the air parcel will become high in temperature, will have higher temperature, it will become loose, or it will tend to move vertically. It will tend to move vertically due to increase in buoyancy, so that will lead to vertically developed clouds, as I have told, cumulus and cumulonimbus clouds. And this is the condition when the atmosphere is unstable. Till this position, you can see, till this position there is stable atmosphere, a stable condition. From this it is unstable condition leading to vertically developed clouds. When the air is stable, it is forming horizontally developed clouds or stratus cloud. When it attains the unstable condition, it will lead to vertically developed clouds or cumulus and cumulonimbus cloud. Okay, so this is the condition which we are naming it conditional instability. Which is conditional instability. You can note the condition that dry adiabatic collapse rate is higher than the environmental lapse rate, and that is greater than the moist adiabatic or wet adiabatic collapse rate. Okay, the air will decrease temperature faster when it is dry, and it will decrease in a slower rate when it is moist. But the environment is having a lapse rate which is in between the dry adiabatic and moist adiabatic. That is the condition of conditional instability. This conditional instability takes place when there is growth of temperature, when there is growth of surface temperature of land temperature during the daytime. As let's take an example. During the morning the air is stable, but during the daytime the air becomes unstable due to greater heating by the solar insolation. So that is the condition of conditional instability, and that will also lead to thunderstorm like events and formation of greater atmospheric unstable condition lead to precipitation. So these are the conditions you can see for absolute stability, conditional stability and absolute instability. At absolute stability, the atmosphere is having lowest lapse rate. At absolute instability, the atmosphere is having highest lapse rate. For conditional stability, that is in between wet and dry adiabatic lapse rate. So these are the conditions, and questions asked in every year repeatedly on this in NET exams. So we'll continue in next videos for next concepts. Thank you.